So what are some failure modes in electric motors? And I think this will be a little fun. First, we need to kind of go to the breakdown of what our permanent magnet motor construction is. If we're looking at automotive, we're looking at aerospace, permanent magnet is the top dog right now. But a lot of the things we're going to talk about do pertain to other motor types as well. So we take our stator. This is the stationary part. We have a laminated core. So we have these thin sheets of steel that create this stator core. We have the windings. In this instance, this is from a Chevy Volt. It's got a bar wound rotor, but we have these copper windings. We then have, rotor hub, bearings. We have the rotor laminations. Again, these are thin sheets of steel that are stamped, pressed together. And inside of those rotor laminations, we can see we have a little skew here to reduce cogging torque. We have the magnets inside of it. In this exploded view, we have these magnets. And then we have more bearings, protective plates. And if we look at this is a pretty simple construction. We have laminations, we have copper, we have bearings, we have rotor, we have magnets. And what the failure modes we're predominantly going to see are in the bearings, because they're rotating, in the magnets, because they're susceptible to thermal stresses, and in the windings, because they're also susceptible to thermal stresses. So those are kind of the three topics we're going to touch on today. So, kind of reiterating what I just said, if we look at the electric machines, what are the faults we're going to see? And again, these are kind of focusing on the more electric magnetic side. We have two categories, stator faults and rotor faults, stationary part, rotating part. And in the stator, we have terminal short circuits. That could be at the inverter, that could be, from winding to winding going to the machine, but this is short circuits before it gets to the motor. We have open circuits, or maybe the windings separate and we no longer have current going through it. Or the real fun one, and this is exciting, is turn-to-turn shorts, or inter-turn shorts, where maybe windings from two phases short together, windings from multiple coils short together, or just windings next to each other short together. And when you have shorts, you have big currents, you have heat, you have really exciting events. On the rotor side, we have electrical failures and mechanical failures. And the electrical failures are going to be broken cage if you're working with an induction machine, broken magnets. This is often on insertion, or if the machine is feeling a really rough profile, or demagnetization. On the mechanical side, we have eccentricities, which is the rotor becoming uneven, misalignments, and bearings. And if we look at a study performed by IEEE and EPRI, the Electric Power Research Institute, we see that the failures in motors are really largely bearings. We got about 40% are bearings. Depending on who you're talking to, 25 to 40, 35% are stator failures. Rotor failures are low, but they, not negligible, 10, 15%. And then other is in the life of rotating machinery, everything else that can happen. So we're going to focus on kind of the bearings, the stator, and the rotor. And fun fact here, it can take less than 2 seconds for an inter-turn short to really permanently damage a machine. So these happen fast. So if we can predict them earlier, there's a lot of value in understanding that, or understanding why it could happen very quickly in 10 seconds from now, 20 seconds from now, 50 seconds from now.